Hello students, welcome to EC Engineering. In this video, I am going to explain you about an polar plot with one example problem. Before proceeding to the problem, I just want to explain you the steps need to follow. Step 1. Consider an open loop transfer function g of s given in a problem and substitute s is equal to j omega over there and write magnitude and phase equation for a given open loop transfer function. Then during a second step, find the corner frequency and choose the number of frequencies around the calculated corner frequency. So find choose the number of frequencies alone, omega value, number of frequencies omega around this corner frequency. Corner frequencies are represented omega suffix c. Say in a given problem, as per the problem, we have a number of corner frequencies. Then consider these corner frequencies and various magnitude and phase angles are calculated. Then draw the table like this for various omega values and calculate magnitude of g of j omega and angle of g of j omega. Then during the next step, draw the polar graph. So before drawing the polar graph, you try to draw the rough diagram. Hopefully you are all well known that how to draw the rough diagram. Even I will explain you once again. For drawing the rough diagram, consider this one, type and order of an system. So for all the cases, type 0 systems are represented here in right side of an horizontal line. Type 1 system, type 2 system and type 3 system. For all the plots started with type and ended with order. Order means this point, this meeting point in between type 0 and type 1 is first order system. In between type 1 and type 2, second order system. So if it happens to be the second order system, that should be ended here. Similarly for 3 and fourth order. Then after drawing the rough diagram, coming back to the actual polar graph. So a polar plot is a plot that is drawn between magnitude and phase of the given g of j omega value, not an h omega, g of j omega open loop transfer function. And this graph sheet consists of concentric circles and radial lines like this. Like this, it has an concentric circles and various radial lines. And these concentric circles represents magnitude. These circles represents magnitude and the radial lines represents phase angle. These lines shows the phase angles. See, these angles are represented negative values in clockwise direction, and from this we need to depict over all the points and find the required gain and phase margin. See here, it has an 0 value and starting from the negative value, clockwise direction, it shows the negative value. Clockwise, a minute angle 10, 20, these are all the negative values. So similarly we have up to minus 90 the smaller value represents 90 minus, and here minus 180 and minus 270. So the smaller values represents negative value in a clockwise direction. In a anti-clockwise we have the positive values. With this enough points, I will pass on to the problem side. This is a given first problem, the open loop transfer function of an unity feedback system where g of s equal to 1 by s into 1 plus s, 1 plus 2s. Sketch the polar plot and determine the gain and phase margin. So according to step number 1, take an given equation. Now substitute g of j omega equal to, instead s we substitute j omega simply. Now write the magnitude of g of j omega. For that consider only real parts of the expression. See here, modulus of g of j omega equal to 1. Here consider an real part omega, then square root of 1 plus omega square into 1 plus 2 square. So 4 omega as omega square. Then multiply both, you will get 1 plus 4 omega square plus 4 omega power 4. So simplify, it becomes 1 by omega into root of 1 plus 5 omega square plus 4 omega power 4. Freeze it as a magnitude equation. Then find the phase angle of an g of j omega. So we know that this is our expression. From this expression, in the denominator side we have all the s terms. So all the s terms becomes with a minus value because it's all in a denominator side. So comes in a minus value. So here in this expression we have only one s term, so that s value takes minus 90 degree. Then here the angle, how to write the angle equation, minus because of denominator side, then tan inverse of imaginary part divided by real part. So here imaginary part divided by real part. Here you have an coefficients of 1 by omega by 1, here 2 omega by 1. So the expression becomes minus 90 degree tan inverse of omega minus tan inverse of 2 omega. Then during the step 2, we need to calculate the corner frequency. Here in the denominator side we have 1 plus s terms. So in this problem we have 2 corner frequency, and this is corner frequency. Rightmost side is in corner frequency number 1, here corner frequency 2. How to calculate corner frequency? Here we taken real part divided by the imaginary part coefficient, that is 1 divided by 2 value. 1 by 2 equal to 0.5 radian per second. Here real by imaginary, 1 by 1 equal to 1, so 1 radian per second. So we have 2 corner frequencies, omega c 1.5 radian per second, omega c2 1 radian per second. So the next step, third step, we need to find the various magnitude values and phase angle values by drawing an tabular column. So we know the magnitude equation and a phase equation. Now we have an corner frequencies 0.5 and 1 value. See, while choosing the corner frequencies, you make a probability by checking an first corner frequency value, magnitude and phase angle, then do calculate with next corner frequency. You have to set right it as an limits 0.5 and 1. Then after, according to our requirement, we have to choose the further frequencies around this 0.5 and 1. First we will calculate 0.5. Well, you are making the values of 0.5 for substituting in magnitude equation. You will get 1.2. By substituting in an phase angle equation, you will get 162. Means here minus 90 degree, minus 90 degree, then minus turn inverse of omega value 0.5, minus turn inverse of omega value 0.5, then minus turn inverse of 2 into 0.5, minus turn inverse of 2 into 0.5, which gives the value 161.5. So we made it as an 162. Similarly, you do for around 0.5 to 1 value, 0.6, 0.7. So while getting an 0.7, we will get near about minus 180 degree. See, for doing an assumptions or around frequency values, we have to concentrate, or we have to keep that in a mind, as your phase angle value gets nearer to 180 degree. So here only you will get an 180 degree. Then do for 0.8 and similar cases. To analyze, it goes on like up to the corner frequency 1. Then try to find the unity value here in a magnitude. Phase angle value 180 or nearer to 180. Then magnitude value, try to get unity value, 1 value. Here it goes on decreasing. So we have to choose an one more frequency which is lesser than the lowest value of corner frequency 0.5. So that we have to choose 0.45 and we will get 1.5. So the one value is nearer here only, in between 0.45 to 5. So for depicting a number of values over in a graph sheet for a perfect free draw graph, we need a few more frequencies. That's why we have chosen 0.4 and 0.35. Then we construct a tabular column. Then after, draw the rough diagram. Here in this given problem, our S term is 1, so type 1, and here an highest order of a denominator polynomial is 3, that's why order 3. So now coming back to, it's an type 1 order. If it is type 1 order 3, it should be comes like this. Means it should be comes like this. We drawn a rough diagram. Now we'll pass on to the actual polar graph. So while drawing a polar plot, consider the graph 0, minus 90, minus 180, minus 270. So these concentric circles represents magnitude. What should be the magnitude value here? Here we have a magnitude values minimum 0.3, maximum 2.2. So accordingly, you have to make a scale for this graph, magnitude graph. So first set and scale. See, here we have a number of circles. Here we have a number of circles. So first choose the origin and try to find the unity circle. And dear students, carefully observe the circles. You can feel some circle in a darker line, inner circle, then outer layer here, and one more outer layer here, and then one more outer layer here. It goes on like this. 1, 2, 3, 4. Up to fourth one, you have a full circle. then after that you have a partial circle only. So you have to choose the value. Maximum you have it for 2.2. So that what we can do, we can make a circle this as 2, then this as 1 and this as 0.5. So you have to consider this circle as an 0.5 value, and this circle is considered as an unity circle. Unity circle. Then after you make a dark line over an unity circle using pencil. Like this, draw the full unity circle. Now depict all the points over in a plot. Find our omega value 0.35, magnitude value 2.2, angle minus 144. So take a graph, angle minus 144. See here 140, so mid 160, here you have an 144. So this angle 144, here an unity circle, see here the concentrated unity circle, here value 2, unity circle, circle number 1 and circle number 2, and this is 0.5. Meanwhile what we consider is, here all the things in a scale is 0.05 magnitude. So after that you have to make an scale. After drawing the things, here you have to make an scale later on. Now coming back to the point, so here we have an value 144 minus 144 and the radial value 2.2. So here 2.2 here, so angle value minus 144 and 2.2 here. Depict the point and write the value omega equal to 0.35. So omega value 0.35. Similarly, we try to do for 0.4, 0.45 up to 1 value in a graph. Similarly, we have to depict all the points here. Now I clearly explain you the first point to draw. Similarly, you do practice. See, minus 144, 2.2. See, I am zoom up here. It is 140. See here, it is 140, 141, 42, 43, 44, 45. Similarly, it goes on up to 150. So if it is 144, 40, 41, 42, 43, 44, this point. So make a scale because your radial line goes on different, well, it closer, closer, closer. Fine. So fix a radial line as it is, and your circle here, unity circle 1, here unity circle 1, here 2. So next one is, see here 2, so 2.1, 2.2, 2.3, 2.4, it goes on. So 144 and 2.2 comes here, this point. This point where your omega value is 0.35. Similarly, we do for 0.4 minus 150. See here, minus 150 and magnitude value is 1.8. So here 2, so here we have 1.8 circle. So 150 and 1.8, yeah, it's here. Omega value is 0.45. You similarly do for all the things. Then after depicting all the points over in a graph like this, we have to start, and as a free hand we have to join the points and make it over start and end point. We already discussed, according to our rough diagram, if taken 0 as reference, see here, we'll take 0 as reference. It is started from type 1 order 3 like this. See here, type 1 order 3. So rough diagram and your actual diagram both are same. Then try to find gain margin. What is gain margin? Is 1 by modulus of g of j omega at phase crossover frequency. What is phase crossover frequency? At what value it crosses the 180 degree. At what value it crosses 180 degree? See here, at the frequency of 0.7. Here also we found the same. At the frequency of 0.7, it crosses 180 degree. See here. So that our gain margin is 1 by the particular omega value 0.7. So our gain margin is 1.4286. Then phase margin. Phase margin we already know, gamma equal to 180 degree plus phase angle at gain crossover frequency. What do you mean by gain crossover frequency? At what value it crosses the unity circle. See here, in a unity circle all the graphs were drawn in a free hand. This particular point it crosses an unity circle. So you just make a point and trace the radial line corresponding angle here. You find the corresponding radial angle here. It is minus 168. So this is the way the freehand drawing where it touches unity circle, correspondingly you drawn a radial line and try to find the angle. It is minus 168 degree. So your phase margin is 180 degree plus minus of 168 means minus 12 degree. So scale also we have to write. So similarly we have completed step 5 and step 6. We found gain margin and phase margin. Students, hope I have given you a clear picture of a first simple problem. If you are familiarized with this problem, we can do the similar kinds of a problem once again. And thanks for your support. Keep on tracing the videos and keep on practice with the problem. Thank you, students.